let's have a flowchart to diagnose which one we're dealing with. So our first question should always be, are we making decisions? And if the answer is no, descriptive analytics, data mining, that's the one for you. And if you want those fancy algorithms, you can use machine learning algorithms for descriptive analytics. You can use statsy stuff like t-tests for descriptive analytics. It's just the way that you use them is very different. You don't worry about the philosophy behind it. You don't worry about whether it's right or wrong. You quickly apply a whole lot of different algorithms and you see if anything seems to inspire you. And whatever inspiration you get, you just interpret that as when this math is applied to these data, the combination together gives me this result. What does it mean? Nothing yet. So if I'm going to go for meaning beyond the data, then I have to look at one of the other two areas. So descriptive analytics in some sense is like a printer. Let's take this image and see what is here. It starts out as a thing on an SD card that we can't make any sense of, so we can't get inspired from it. Well, let's look at it and see if there's any inspiration. And just like with photographs, you should know that if you are walking down the street and you stumble upon some image lying on the pavement, you shouldn't pick that up and learn all kinds of marvelous things beyond that photograph. Data science is essentially Photoshop. You can do benign things with Photoshop, like have a look at what is here. You can also slice it and dice it and make it tell any story you want. So if you want to use that photograph for decision-making beyond what's in the image, you need to be in control of how that image was taken, and you need to be in control of what has to be in that photograph in the first place to sway your opinion. If you just found some data lying around and you looked at it, please don't take it too seriously. All it says is, this is what happens to be in this particular image as it is sitting in front of me. And that could be inspiring. Just don't learn more from it than you should. Next question. If we are making decisions, can we just look up the answer? So maybe our decision is directly based on last year's revenue figure. Let's look up last year's revenue figure and off we go. Well, back to descriptive analytics, just look up the answer. You're dealing with facts. But if you can't look up the answer because all the data you care about isn't available to you, like you care about tomorrow's data and you only have today's data, well, then you have to deal with one of the others. So then the next question is, how many decisions? And if your answer here is many, machine learning is what you want. And that is where we build a recipe out of today's photos, out of this pile of photos, that we might use for determining whether we have a truck in a photo we take tomorrow. We're making a recipe out of our old data to succeed in new situations. If the answer is few, next question is, are we scared? Is the decision important? Because if the decision's like, hey, based on what's going on in fashion today, should I buy a blue t-shirt or a white t-shirt? Please don't waste your PhD statistician's time on this. Get inspired and go buy your t-shirt. It's only when the decision is important, when it matters, when you want to make it carefully, rigorously, in a risk-controlled manner, that you want statistical inference. And in order to purchase that rigor and careful control, all the conditions need to be carefully put in place. You don't get those guarantees just by sort of math on some bad data and off we go. Everything has to be done carefully, especially the framing of the conditions at the beginning, which the decision maker makes. So what's a really careful risk-controlled decision that we might want to make? Should we launch this machine learning system we've built? This is a system that's important. If it doesn't operate correctly, we'll lose all our users. Should we release it? Yes, no. That seems like a pretty important decision that we might want to verify with statistical inference. So I kind of think of machine learning as make it work, and statistics as now that you think it works, does it? It's about coming to conclusions beyond our data safely.